Kia ora, Year 12 and 13. This is question 1B from the 2015 Scholarship Calculus paper. So this is a little differential equation question. When you first read it, it looks a bit awful, but it's actually something that could have been in the level 3 paper, I think. So we're asked to determine all differentiable functions of the form y equals f of x, which have the properties this, the first derivative, equals the function cubed, and then we're given a particular value. The value of the function at 0 is equal to 2. So there are some different ways to do this, but I find it easiest to rewrite this using Leibniz notation. So we're going to get this. dy by dx is equal to y cubed. So we'll start from there. Now we'll do pretty much the only technique we have in our toolkit, which is to separate the variables out. So we've got 1 over y cubed dy is equal to 1 times dx. Okay, some of you might not have done this in class just yet, so just watch how it goes. So here we've got y to the negative 3 dy is equal to 1 dx. So here we're treating, when we do separating the variables, we're treating this very much like a fraction, and I'm not going to go through why we can do that here, but it's a little bit like doing implicit differentiation. So I'll talk about that more in class, not in the video. What I get to here is I've separated out my variables, so I'm now going to integrate both sides with respect to the variable. So up here we just do this, so y to the negative 3 integrated with respect to y is equal to this. Okay, so not too bad. And we get negative 1/2 y to the negative 2 is equal to, on this side, well, 1 anti-differentiates to give me x, and we're going to pop in our constant of integration. Now, we only need to have one of these, so we don't need a plus c on both sides. So this is an arbitrary add factor that when we differentiate will disappear. So that gives me this, negative 1 on 2y squared is equal to x plus c. And that's as far as we can go for now. That's a general solution. But we know that f of 0 is equal to 2. In other words, the point 0, 2 is on the curve. So we're going to substitute that in now, and I'll do that on the next slide. Alright, so just recapping, we've got negative 1 over 2y squared is equal to x plus c, and we know that 0, 2 is on the curve. So negative 1 over 2 times 4 is equal to 0 plus c. So that leaves me with c is equal to negative 1/8. Right, so I'm just about finished. I can substitute that back in. What we're looking for now is an equation for y. So we've got negative 1 over 2y squared is equal to x minus 1/8, which is equal to 8x minus 1 over 8. Just popping the left hand side back in, there we go. Alright, let's see if I can get this done on one slide. Now I can multiply both sides through by 2, so we have negative 1 over y squared is equal to 8x minus 1 over 4. Y squared is equal to, so y squared over negative 1, doing this very slowly, is equal to 4 over x minus 1, 8x minus 1. So y squared is equal to 4 over 1 minus 8x. So we're almost done. Okay, the last thing I need to do is to take square roots of both sides. I'm going to try and squish that in on here. Sorry about the squishing, but there you go. So y is equal to plus or minus the square root of 4 over 1 minus 8x. Now there's one last thing we should say in there, and that's that x may not be equal to 1/8, because that would give me 0 in the bottom line. Alright, that's that question done. Thanks for watching, and there'll be some more scholarship videos coming up soon.